This is a tour of the TD7 display that is mounted to the front of the UC600 panel on both air handler 3-3 and 3-4. The laptop view that we're seeing here has the exact same view that will be on the TD7 screen. It's just the portion in the upper left-hand corner. My finger is showing the boundary of what will be shown on the screen. So this display screen is what you will see when the unit is powered up. So it's the air handler schematic with a variety of points and information around the edge. Now we're going to shift from the AHU graphic to the diagnostic screen. This screen provides a summary of all of the potential alarms that can be generated. You'll see a complete list and description of these on the diagnostic screen page of the Air Handler Controls Operations Manual that we put together. We return back to the home screen, which is the air handler schematic. And now we're having a conversation about what happens when power is first applied to the air handler. We've left the air handler in an unoccupied status. So we'll soon click on this occupancy request button in the lower right hand corner and shift to a screen that allows us to toggle the occupancy request to occupied, which will allow the supply fan to start and the air handler to begin normal operation. During the training session we had before the air handler shipped to its overseas location, we discovered that we had the occupancy request set up as occupied. In that scenario, when power was applied to the air handler, the supply fan would have immediately begun to run. We've changed this, and we're actually changing it right now on the screen. We're going into the override screen, and we're going to change the standard occupancy setup to be unoccupied. You'll see two overrides on this list. The second one is an outside air damper override, which we actually only had temporarily set up for the purposes of our training session before the unit shipped. That won't be present. That override will not be present when the unit shows up. So this is now showing clicking in the upper left-hand corner to release the override from the unoccupied status, and that will allow the air handler to start. So again, when you see the unit and power it up, it will be in an override situation, unoccupied. You'll click on that occupancy setup and click the override release, and the unit will start the supply fan. We've now shifted to the detailed alarm list that gives the time of any alarms that occurred, and we're now going to compare it with the alarm summary page, which is also called the diagnostics page, which gives the list out of all of the alarms. Again, you'll see a description for each of these alarms in our Air Handler Controls Operations Manual. The other discussion we had with this page is that all of the alarms clear themselves whenever the condition returns to normal. So as an example, the high discharge air temperature alarm occurs at 60 degrees Fahrenheit. When the air temperature returns to below 60 degrees, that alarm automatically clears. It does not require any user interface to clear the alarm. The same would be true for high CO2. High CO2 alarm is at 1,000 parts per million. When the CO2 level measured by the CO2 sensor in the return ductwork returns to below 1,000 parts per minute, that alarm would clear. The only example of an alarm that doesn't automatically clear is the supply fan status. The supply fan status is set up so that when the air handler supply fan is told to run and it doesn't return a running status, it will go into alarm. That doesn't stop the fan from running, so if we simply have a failure of that status indicator, then the supply fan will continue to run and the alarm will show up. When the supply fan status indicator is fixed, then you would go into what you see in the center bottom of the screen, the supply fan failure reset, to toggle that condition back to its non-alarmed condition, and the screen would return to normal. But again, all other alarms automatically clear when the condition goes back within the acceptable range. Now we're going to shift to the Setpoint screen. The Setpoint screen has two really important things to keep in mind. One is the priority. There are 3 locations where the space temperature set point can be entered. The first is at the operator display. That's the TD7 that we're looking at that will be connected to the UC600 control panel, physically connected to the left side of the supply fan section. The second location where space temperature desired can be entered is on the thermostat in the space. The third location is a fixed set point that is entered into the program. So now let's talk about priorities. The top priority is actually the operator display, so that display that's connected to the supply fan section. In the top line of this, you see the feature Disable Operator Display Space Temperature Set Point. So if that is off, in the off condition, that means that it is not disabled and that the operator display set point is actually going to determine the supply fan speed. You'll notice at the second item up from the bottom is Space Temperature Set Point Active. So the temperature that's there is being fed from the operator display temperature. So that's the second item from the top. So again, the operator display disable on the top line. If that's off, then the space temperature that's entered on the second line is actually going to show up on the second line from the bottom, which is the space temperature set point active. The next priority is the space temperature sensor that's actually located in the space being served. So you can disable that feature if you don't want the users to be able to manipulate temperature in the third line item from the top, Disable T-stat Space Temperature Set Point. If both of those, the operator display and the space temperature set point, are disabled, then there is a third choice which is embedded in the program. One additional temperature to be aware of is the bottom item on the list, Discharge Air Temperature Set Point. The discharge air temperature set point is used to control the chilled water valve. The space temperature, whether entered and used from the thermostat in the space or on the TD7 operator display or from the temperature embedded in the program, as the list of priorities we previously discussed, those temperatures drive supply fan speed. This bottom item on the list, discharge air temperature set point, again is used to control the chilled water valve so that we get a consistent discharge air temperature. Let's review this one more time, as it can be a bit confusing. In a scenario where the operator or installing contractor wants to set up the equipment so that the facility manager has control of the space temperature, you would enter the desired space temperature at the display connected to the air handler. You would, on the top item, have the Disable Operator Display Space Temperature Set Point off, i.e. not disabled. On the third item from the top, Disable T-stat Space Temperature Set Point, you would actually have that in the disabled.